Today, we're going to talk about energy, the environment, and justice. All right. You guys have already gotten into the resource-specific topics, but today is a cross-cutting topic that helps provide a bird's eye view of uh, energy's impact on the environment and the implications for our society. And you'll see these topics kind of come up throughout the rest of the course. Does anyone know what this is a picture of? It wasn't a mistake. It's our home. This is Earth. Photo taken in 1990 by the Voyager 1 space probe about 6 billion kilometers away, past Pluto. So that little pixel there, that's us, as astronomer Carl Sagan calls it, that mote of dust suspended in a sunbeam. So I hope today's lecture, like this photo, helps give you a little bit of perspective on the significance of energy and its environmental impacts in our lives. All right, a little bit of energy in the news that's relevant to today's topic. Over the past few months, the federal administration has increasingly deregulated, reduced regulations of environmental impacts of human activity, and in particular, energy use. This is a press release from the Environmental Protection Agency, which is the primary federal agency that regulates environmental impacts, water, air, waste, etc. And you can see that the EPA Administrator, Lee Zeldin, has been busy deregulating a lot of policies and actions and enforcement mechanisms by the EPA. And we'll talk more about that, but even just this week, the Trump administration also issued an executive order directing agencies to reduce regulations associated with a variety of different environmental legislations and policies. So today we're going to talk about what does this actually mean, right? And what does it mean for the energy sector, and what does it mean for us and for the environment? But first, let's talk about why we even care about the environment. So what does the environment mean to you? Why do you care about nature and the environment? We hear from a lot of students that they take this class because they care about the environment and energy's impact on it. Part of why I really came to the issues of climate change and energy and the environment is because my family has a ranch in the Sierra Nevada foothills, and growing up seeing the kind of fragile interaction between human activity and our food supply, our gardens, and even small reductions in precipitation could mean that we don't have a good crop, right, that year. Why we care and the way that we as a society think about the environment today has evolved over time and is very different than a couple of decades ago and even a couple of centuries ago. And I want to talk about kind of the history of how society has interacted with the environment. So looking back in history, philosophers, poets, and writers like Jean-Jacques Rousseau and William Wordsworth, Henry David Thoreau, they all heralded the environment as this sort of Eden, a place to be protected because it has inherent ethical value on its own, separate from humans. Fast forward to the early 1900s, and we saw the emergence of the preservationist movement, led by people like John Muir, who engaged in activism around protecting the environment. John Muir started the Sierra Club in 1892, which was one of the first large-scale environmental nonprofit organizations in the world. And John Muir, on the right up here, he echoed Rousseau in that he believed that in the intrinsic value of nature and wanted to eliminate human impact on it. This is a famous photo of John Muir with President Teddy Roosevelt in 1903 in Yosemite National Park, which is a national park that is about a 4-hour drive from here. If you haven't been, I highly recommend it. And it's the trip that convinced Teddy to make Yosemite into a national park. And John Muir was so successful in preserving the park that he was able to get the Native Americans that lived in the park, the Awanichi, basically kicked out. And as we're all hopefully aware, this is a story that has played out in history many times over, not just in the US, but also globally. There's a great resource in the notes of these slides that allows you to look at where native lands are across the US, and including where we are now on the Muwekma Ohlone tribal lands here at Stanford. So preservationists, they wanted to eliminate human impact on nature. Although this was a huge milestone in the work of John Muir and similar preservationists continued during this time, the environmental movement largely remained fringe at this time and for several decades thereafter, particularly in the midst of the World Wars and the Great Depressions, and even into the 50s and 60s. I remember when I first took this class, Jane would tell stories about how her father, when changing his car oil, would just dump the oil down the drain, right? But now there's regulations and laws and much more societal norms around not doing things like that. Fast forward again to the 1960s and 70s, when you have environmental issues really start to grow on the public agenda. And we saw, as a result, an increase in environmental regulation and civil society efforts. Some key milestones during this time: Rachel Carson published her seminal book, Silent Spring, that spotlighted the harmful effects of the pesticide DDT on wildlife and people. DDT was pretty much single-handedly responsible for putting bald eagles on the endangered species list. Something that, thanks to regulation since then, has, the bald eagles are no longer endangered. Around this time is also when the Federal Clean Air Act in the US was first passed. And the Clean Air Acts are a significant and very successful policy that has been expanded over time to regulate air emissions, to make sure that we can continue to breathe clean air. Again, the Environmental Protection Agency, the EPA, is the entity that enforces and implements the Clean Air Acts. That was also established around this time in 1970. We also had our first Earth Day, and I think that was in 1970, coordinated by Stanford alum Dennis Hayes. And we've got another Earth Day coming up, I think, in a little over a week, which is exciting. I'm sure there'll be lots of good events around campus. And we also saw the birth of many environmental nonprofits, environmental NGOs, including the World Resources Institute, which is the nonprofit that I worked for several years ago, too many years ago, right out of college. We also saw continued and maybe even an acceleration of environmental crises, like the Love Canal, which was a neighborhood in New York that was built on a toxic waste dump. Or the Exxon Valdez oil spill off the coast of Alaska that had huge environmental impacts on the marine life there. And an acceleration of deforestation in the Amazon as well, all of which continue to fuel the environmental movement. So fast forward to today, when one of the terms that has really come to define society's relationship with the environment is the term sustainability and sustainable development. And this phrase, it has a very, very specific origins. It was coined in the 1987 report by the United Nations called Our Common Future, that was led by former Prime Minister of Norway, Gro Brundtland. And the report defines sustainable development as that which meets the needs of the present without compromising the ability of future generations to meet their needs. And it also balances three pillars, that of economic growth, environmental protection, and social equity. So hopefully this historical arc around our environmental history gives you an indicator of how the society has come a long way since the time of Rousseau and how we think about and manage our environment. But it's also in part because we've had to, right? As we've continued to industrialize and urbanize, environmental issues like climate change have moved from being hyper-local to global. in a more complex world, we've really needed to advance our ability to manage human impact on the environment. All right, another important development in our environmental history is the emergence of the environmental justice movement, as we were talking about earlier. Black communities and people of color in the US in particular bear a disproportionate burden of environmental and climate impacts of human activity, including our energy use. And it was because of this that in the 1980s, we saw the emergence of the environmental justice movement in the US. In this photo, the residents of Warren County, North Carolina, which is a predominantly Black community and one of the few counties in North Carolina with a majority Black population, came together in 1982 to protest the siting of a proposed toxic waste disposal plant in their backyard, which really is a key historical event highlighting environmental injustices and environmental racism in our country. And that spurred the environmental justice movement. There are a lot of ways that social inequities relate to energy in the environment in the US, and we're going to focus on the US today, but as we talked about in the climate change lecture, there are global inequities as well related to how different countries, particularly those in the developing world, are most impacted by climate change that has been primarily caused by the developed world. But today we're going to focus and hone in on those inequities and injustices in our own backyard. These injustices and inequities, they have really clear and intentional origins. In the US, many studies show that the racial profile of your residential community is the single biggest factor that determines whether you live near a hazardous industrial facility like a chemical plant, a coal mine, a refinery, or a toxic waste dump. And this wouldn't be possible without racial segregation. Almost every major city in the US has some level of racial segregation. Shown in this map here, the warmer colors show level of racial segregation in different communities, which, if you look at the Southeast, there's definitely a lot of racial segregation. But if you zoom in, pretty much every city you can see has some form of racial segregation there. And the origins of this segregation date back to intentionally prejudicial federal housing and zoning policies in the 1940s and 50s that were able to quite successfully divide communities along Black and white lines. This is a process that's known as redlining. And these patterns of segregation have proven very hard to reverse and also detrimental to these communities. Because these Black communities, they often experience a lack of investment in public infrastructure. They have less of a voice in local government and zoning laws. They're often zoned for industrial operations, which makes it really hard for them to say, not in my backyard, when an industrial plant or toxic waste dump tries to come into town. And these Black communities, they also have lower property values. They have longer commute times, less access to well-funded public schools, less parks and outdoor spaces, and high instances of pollution. So the consequences of all of this are that Black communities, they bear the greatest burden of the environmental impacts of our energy usage. And we'll circle back to this as we talk about each of the different types of environmental impacts that come from energy usage and what that looks like in the context of disproportionate impacts on people of color and low-income communities. There are a lot of words on this slide, and I apologize, but I also wanted to make sure that I captured the history of federal action on environmental justice, the very long history, because right now it's no longer available on the federal government's website. As we talked about, the federal government right now under the Trump administration is trying to significantly reduce environmental regulation and also trying to reduce efforts related to environmental justice and equity. And as you can see here, we have a long bipartisan history of presidential administrations implementing really important policies and programs to address environmental injustices, dating back, to the early 80s when we saw the birth of the environmental justice movement. That Government Accountability Office study was really motivated by that Warren County protest that we talked about earlier in North Carolina. And we saw, President George Bush Sr. create the Environmental Equity Working Group that ultimately resulted in the establishment of the Office of Environmental Equity, something that was renamed to the Office of Environmental Justice. We even saw kind of a reaffirmation of President George Bush Jr. To environmental justice and continue to advance solutions under his tenure. There's a lot more that has happened beyond even what's on this slide. And again, this link doesn't work, but I don't know if anyone here has used the Wayback Machine. If you want to make it work, basically you type that link into Wayback and you can find a variety of different information from web pages that were archived, including from the federal government, which I've been using a lot more recently as the federal government has taken down important tools like, and web pages like this one, or like the low-income energy affordability tool. So in a huge milestone in federal environmental justice policy, under the Biden administration, President Biden passed an executive order that set the goal that at least 40% of the benefits of certain federal grant programs flow to disadvantaged communities. And this became what is known as the Justice 40 initiative. And this was really significant because during the Biden administration, there was significant legislation that made hundreds of billions of funds available for clean energy and climate action under the Inflation Reduction Act and the Bipartisan Infrastructure Law. And what this did is basically prioritized a significant portion of those funds for disadvantaged communities in a way that, at a scale that we'd never really seen before. Related to that, it's really important to have data on where those communities are so you can better target solutions and resources for those communities. So in 2022, the Council on Environmental Quality launched the Climate and Economic Justice Screening Tool to provide transparent data to help identify those disadvantaged communities. Yeah.
How do grants make sure the benefits are going to the disadvantaged or low-income communities?
Yeah, it's a great question and a great point. I mean, each kind of grant program has determined that differently. I'll give you an example. You've got the Solar for All program that the Nevada Clean Energy Fund, my organization, is implementing in Nevada. And we were awarded $156 million to support solar projects that benefit low-income communities. So it could mean that, say, we're building a solar project that's located in a disadvantaged community as defined by the Climate and Economic Justice Screening Tool. But primarily what it ultimately means is that we're sending benefits from the solar projects directly to low-income and disadvantaged households. In the case of Solar for All, it's really just like we're putting a solar project on a household that's low-income or disadvantaged, and so we screen for this. It gets a little bit harder when the website's not available anymore, but we still have the census tracts. But I mean, it's a really important question because there are significant amounts of census tracts that are considered disadvantaged, and you could put a solar project in a disadvantaged community and maybe it doesn't benefit that community. So it's an important question about how is this actually enforced in practice. But there is an alternative. I think there was a kind of recommended tool. The CGS tool was included in Canvas for today. There is an alternative website that basically took the archive of CGS and recreated the map. So you can go in and look at where are the disadvantaged communities, in your neighborhood. Fast forward to today, we've got President Trump has basically rescinded the Justice 40 executive order and issued a new executive order to end programs related to diversity, equity, inclusion, and environmental justice. So since then, we've seen a lot of efforts by President Trump and his administration to roll back anything related to environmental justice, including trying to fire staff within agencies and departments, trying to roll back grants, including grants that are legally obligated. So it's very questionable whether or not the administration can legally do that. And in fact, we've already seen litigation with a federal judge ordering the government to stop doing that because it doesn't appear to be legal. And it's definitely something to follow. I mean, there's a lot of litigation ongoing right now related to the Trump administration's actions across the board. The first step in that litigation will typically, you'll see a preliminary injunction, then you'll see a permanent injunction, and then ultimately final orders from the Supreme Court if that's appropriate. So this is ongoing and something to continue to follow. All right, so as we talked about earlier, regardless of whether you consider yourself an environmentalist, it's important to understand that the environment provides us with critical ecosystem services like clean water and clean air that are critical for us to live on this planet. And these ecosystem services, they can be measured and valued. For example, a recent Yale study found that the ecosystem services damaged by our fossil fuel usage in the US amounts to about $62 billion a year in damages to the environment, to climate, and to human health. And that's not priced into the private cost of our fossil fuels, of, say, purchasing gas at a gas station. I want to call out this amazing book, if you haven't read it. It's called Braiding Sweetgrass. It's about an Indigenous woman, Robin Wall Kimmerer, who's a PhD in ecology, and she teaches biology at a university. In this book, she draws on both kind of Western science related to our ecosystem and biology, and reconciles it and combines it with indigenous wisdom about the natural world. And I love this quote about how in some native languages, the term for plants translates to those who take care of us. All right, so the reason why it's important to quantify ecosystem services is because you can't manage what you can't measure. You have to price in both the positive and negative externalities of an activity and the goods and services that we use in order to understand the total costs and benefits to society and make strategic decisions about human activity accordingly, whether or not you're a policymaker, an individual consumer, or a business. So I think Diana talked to you about externalities in the first lecture, and the fact that there is, often this difference between the private costs that we pay for a good or service and the total cost to society. And it's hard to manage the externalities of natural resources in particular because natural resources are what are called common goods. And common goods have two key characteristics. They're rivalrous and non-excludable. Rivalrous means that use of the resource diminishes its availability to somebody else. So, for example, if you and I are neighboring farmers next to a pond, if I use that water, there's less of it available to you to water your plants. So, water is a rivalrous resource. So in addition to being rivalrous, common goods are non-excludable, meaning that it's really hard to keep someone from using that resource. Like it's hard to keep someone from breathing the air, right? So natural resources like fisheries, like fresh water, the carbon budget, these are common goods. And because they're common goods, they experience what is called the tragedy of the commons, whereby individuals acting independently and in their own self-interest will ultimately deplete a shared, limited common good, even if it's contrary to the interests of society and the individuals. So the implications of the tragedy of the commons is really significant, right? It means that if we don't cooperate or regulate our natural resources, we will ultimately deplete them. These charts, I think we like to fit a lot of charts on a slide, as you probably come to realize in this class, but they help us get some perspective on what the tragedy of the commons looks like right now in the world as a whole. But they show that since the 1950s, we've seen an acceleration of population growth, of economic growth in the form of GDP or gross domestic product, and urbanization. And with it, a significant acceleration of demand for goods and services like energy, fertilizer, and paper, and fresh water. And as a result, we've seen increasing levels of pollution and depletion of our natural resources, such as forests and fisheries. One thing I want to call out in these charts on the left, they're broken up by different gradations of orange that indicate different parts of the world and their role in this acceleration. So the darker orange at the bottom, these are the OECD countries. That is a term used to describe the developed world largely. But one of the things that you can tell is that more than 80% of population growth has come from the non-OECD countries since the 1950s. In particular, the BRICS, Brazil, Russia, India, China, and South Africa. But the vast majority of GDP growth has come in the developed world, the OECD countries. So the challenge and the tragedy of the commons that we're faced with is, as the population in the developing world continues to develop economically and demand the same goods and services as the developed world, how do we do that in a sustainable manner without entirely depleting our natural resources? All right, this provides a summary of a variety of the different environmental impacts of our energy usage and energy's contribution to those environmental impacts. We're going to dive deeper into each of these, but the overall takeaway from this chart is that our energy usage is one of the biggest contributors to many environmental issues across the board. And before we dive into those specific environmental impacts, I just want to make a note on systems thinking. Environmental impacts, they occur all throughout the life cycle of an energy resource system, from extraction to end use. Everything we do has an environmental impact. There's no free lunch, right? For example, even though renewable energy generally has lower environmental impacts than their fossil fuel counterparts, they still have environmental impacts. Wind turbines could hurt birds, for example, or manufacturing of solar panels takes energy. These are things that, regardless of whether you're working on fossil fuels or renewable energy, you have to think about and manage. The other point that I want to make here is that when you're approaching an issue, it's important to think about the whole system and not just silo in on one aspect of that system. For example, let's say you're tasked with thinking about how to reduce water usage. And you might propose that people take less showers or that you don't bring water to the table at restaurants. But if you take a step back and look at overall US water usage, you'd realize that water usage in homes and commercial buildings is a very small portion of overall water consumption. We'll actually break this out later in lecture and look at energy usage's contribution to water usage. But by and large, the largest source of water consumption in the US is agriculture. So if you take this bigger perspective, then you might think about different ways that you can engage in policy or technical solutions to help farmers reduce their water usage. And similar story with climate change. If you only focus on your own greenhouse gas emissions impact, then you might rob yourself of the broader opportunities to help reduce greenhouse gases and impact climate change. You've got homes being such a small portion of greenhouse gas emissions in the US, and even if you zoom out even more, the US is just one part of the bigger picture of contributions to greenhouse gas emissions. So part of what this lecture is about and what we try to do in Understand Energy is help you think about how you can make a difference in your lives, not just with your own personal decisions, but also how you vote, how you engage in your career, and the conversations that you have with your peers. we're going to talk about the different environmental impact categories and how energy contributes along those different categories. Air, water, land, and wildlife. And normally I show a picture of like Delhi or Beijing that have often significant and chronic poor air quality on this transition slide. But today we're looking at a picture of San Francisco in 2020 when California had experienced several major wildfires and the Bay Area was just blanketed in smoke. And there have been several studies that link the increase in wildfires to climate change, increasing temperatures and reduced precipitation, including a study out of Stanford with Stanford professor Noah Diffenbaugh, which, as we talked about last Friday, our energy usage is the biggest contributor to greenhouse gas emissions. So sometimes the link to poor air quality might be indirect between poor air quality and our energy usage, but it's definitely there. Let's talk about how air pollution happens from our energy usage. So what are fossil fuels made up of chemically? Yeah, hydrocarbons. And what happens when we burn them? Yeah, well, it combines with oxygen and we get, oh dear, I should have gone over there. Carbon dioxide and water. All right, what else might happen during this process? Yeah, partial combustion could result in carbon monoxide. What else might come from partial combustion? Yeah, particulate matter. Yeah, that's great. Yeah, especially if you have like dirt or other things in your fuel. Particulate matter we'll talk about is one of the most dangerous air pollutants. It is the most dangerous air pollutant. Yep. So if you have sulfur in your fuel, then you're going to end up with sulfur dioxide or sulfur oxides. All right, and then also if your flame is burning hot enough, then it might combine nitrogen in the air with the oxygen. So you're getting NOx as well, nitrogen dioxide or NOx. All right, and then also a product of incomplete combustion or evaporation of your fuel, like if you've got, oil sitting in big oil tanks that are uncovered, it might evaporate. The result is what's called volatile organic compounds, or VOCs. And VOCs are a broad category of pollutants that describe anything that can change easily from a liquid or a solid to a gas or a vapor easily. So when you go to a gas station, you're probably smelling VOCs. VOCs also occur naturally in nature, like if you're in a forest and you smell pine trees. So very broad category, sometimes they can be carcinogenic, sometimes they're not, especially those natural ones. But methane is actually a volatile organic compound, as well as being a greenhouse gas. So VOCs, they can come from direct emissions, like if you have a gas leak in your gas distribution system, a natural gas distribution system, evaporation of your fuel, like we talked about, or incomplete combustion. Okay, so we've got VOCs. Okay, anyone know about secondary air pollutants that might form from these guys? Well, if you combine VOCs with NOx and sunlight, then you get ozone or O3. Or ozone, which is good up high but bad down low. It's the second biggest killer from an air pollution standpoint after particulate matter. And then if you combine ozone with particulate matter, that's how you get smog. So this is just a summary of what we talked about. Basically, if you burn, evaporate, or emit a hydrocarbon, the result is you have air pollution. So let's talk about the different types of air pollution. We talked about greenhouse gases, which are kind of in a category of their own because they act a little bit differently. They're much more global rather than local. And the result is climate change that we talked about last Friday. You already know that energy use is the biggest contributor to our greenhouse gases, both in the US and globally. Different energy resources have different levels of greenhouse gas emissions associated with them. This chart, it shows the results of a study by the Intergovernmental Panel on Climate Change that that ultimate scientific body on climate change. It surveyed hundreds of different peer-reviewed studies on greenhouse gas emissions from electricity resources in particular, looking at the entire life cycle, so both upstream and downstream. The diamond in the middle is the median from the studies, and then the green bar is the range. And you can see that the renewable energy resources generally perform much better than their fossil fuel counterparts at the bottom in terms of greenhouse gas emissions, with a couple of exceptions. You've got hydropower. The greenhouse gas emissions involved here are a result of methane release and the continual flooding of vegetation that happens with the big hydroelectric dams, which make up the bulk of hydroelectric capacity in the US and worldwide. So the wide range of potential emissions could also be due to a couple different factors as well. First is that most of our hydroelectric capacity in the US wasn't built for energy purposes. It was built for flood control and irrigation purposes. So there's an argument that the greenhouse gas emissions associated with that shouldn't be attributed to the byproduct of electricity that happens. That was kind of a secondary or tertiary benefit of these systems being built. Another reason why you've got that wide range is that you can also have smaller run-of-river hydropower projects that don't result in a backup of water that results in the methane release. But that's relatively a smaller portion of our hydroelectric capacity in the US. Biomass, too, here at the bottom could have significant greenhouse gas emissions associated with it, depending on what feedstock you're using. Corn ethanol, for example, can be very energy intensive because of all the energy that goes into growing that corn and the land use that results in greenhouse gas emissions as well. All that said, by and large, the bulk of our energy-related greenhouse gas emissions do come from fossil fuels. So that's greenhouse gases. Let's transition to talking about the other air pollutants that come from our energy usage. And you can see all the different air pollutants up top here and what their main sources are between power industry, transport buildings, fuel supply, and non-energy like agriculture. So these air pollutants, they have significant implications for our health, not just for humans, but also for the environment. Particulate matter, as we talked about, it's considered the most deadly, and it's categorized in two different ways in terms of their size, in terms of microns or micrometers. You've got larger PM, which is PM10, or 10 micrometers, and smaller PM 2.5, which means that it's 2.5 micrometers or smaller. And to give you a sense of scale, a micrometer is about 1/50th the size of a strand of hair. So it's tiny and it's invisible. You can't really see it. And that's why it's so dangerous, because it is so small. It can get into your bloodstream. You can breathe it in really easily and get into your organs and result in things like cardiovascular disease or lung cancer. And you know, as we talked about earlier, PM, even though it's not a greenhouse gas, it also contributes to climate change in a more localized manner in the form of black carbon. So that's particulate matter. We've also got lead and mercury that are both what are called bioaccumulative, which means that our bodies have a really hard time processing them, organisms in general. So because of this, you've got top predators like tuna that can often have significant accumulations of lead and mercury in their bodies from the prey that they eat, which is why pregnant women aren't supposed to eat tuna. In the US, we've been fairly successful at regulating most, if not all, of these air pollutants, in particular through the Clean Air Acts, but also through the Mercury and Air Toxic Standard that I believe came into effect in 2012, that regulates mercury. And you know, even CO2 as well. The history of Federal regulation on CO2 has been a challenging one, but in 2009, EPA issued their endangerment finding that found that CO2 has a negative impact on human health, and as a result, EPA could regulate CO2 under the Clean Air Acts. But that's something that EPA has said that they're revisiting recently, as well as all of these other regulations, unfortunately. We talked about the different characteristics of air pollutants and their impacts on health, but what this means in practice is that air pollutants have a huge impact on human health and are a significant cause of both death and morbidity. The impacts of air pollution, they're often secondary or tertiary, right? Like, not everyone attributes lung cancer or strokes to air pollution, but there are a lot of studies and peer-reviewed studies that have made that link. And it's not just deaths resulting from air pollution, but also reduced quality of life as a result of chronic illnesses like asthma and even mental health challenges that have been linked to poor air pollution. About 1 in 5 deaths worldwide are attributed to air pollution. In the US, air pollution is the number 3 cause of death, with about 200,000 deaths annually attributed to air pollution. And deaths from air pollution are even worse in the developing world, with about half of those deaths attributed to outdoor air pollution and the other half attributed to indoor air pollution as a result of the use of dung and wood for heating and cooking, something that you'll talk about more in the developing world lecture. And as I've talked about, the EPA and the federal government is rolling back regulations on these air pollutants and other water and land pollution as well. And you can imagine that that's going to have significant implications for increasing these health impacts related to that air pollution. All right, so you can see on this map how deaths from air pollution vary by country, but deaths from air pollution also vary within the US by region. Again, as we talked about earlier, there have been countless studies that show that Black and Hispanic populations in the US are historically exposed to air pollution, with a 2017 study finding that Black Americans are 3 times more likely to die from exposure to air pollution than other groups. And that's because of that historical segregation that we talked about, the redlining and the resulting policies and impacts in those redlined communities. This is a picture of a community, a predominantly Black community in Orlando that has been pretty successfully redlined to be surrounded by highways. And the air pollutants that are most deadly, they occur in higher concentrations close to what the source of pollution is, like highways, refineries, coal trains, and power plants. So this is one of the reasons, obviously, that those red line communities, predominantly Black or other communities of color, are disproportionately exposed to those impacts of that air pollution because they're sited next to highways, to railroads, to refineries, coal trains, you name it. All right, so that's air pollution. Let's transition to talking about water impacts of our energy usage. And there are 3 main categories of water impacts that I want to talk about. You've got withdrawals, consumption, and contamination. So water withdrawals refer to withdrawing water from a source that you ultimately put back into that same water source. So the most common water withdrawal in the energy sector is with thermoelectric power plant cooling, where, as you talked about with Diana in the first lecture, I think, you need thermoelectric electricity generation requires the steam cycle, which requires a cold sink, right? And water is typically used to provide that cold sink, like from a lake or an ocean for cooling. So in that process, you take water out of whatever water source, you use it for cooling through your steam cycle, and then you return it back into that same water source, albeit typically a little bit warmer than when you first took it out, but you still return it. So that's considered a withdrawal. With consumption, unlike withdrawals, you don't return the water to the original source. So, for example, if you're watering your crops, you you're not returning that water to the original source. Another way to think about consumption is water displacement, because of course we live in a closed system. It's not like that water disappears. And then you finally have water contamination. For example, like when air pollution like lead, mercury, and SOx settle into the water, or with coal ash, which we'll talk more about. All right, so water is consumed throughout the energy resource system, from upstream extraction or capture, like oil and gas drilling, coal mining, equipment manufacturing, to the conversion, like electricity generation, where, as we talked about, thermoelectric power plant cooling is a big component during the conversion stage for electricity. And then downstream waste management, whether you're talking about coal ash as a result of coal-fired power plant or nuclear waste. Hopefully there's not too much water involved in that one. And if it is, hopefully it's contained. All right, so where do you think most of water usage occurs in the energy system overall? Conversion, yes, exactly. That thermoelectric power plant cooling. Sometimes when I ask that question, folks will say oil and gas drilling. They'll say upstream because there's been a lot of focus on hydraulic fracturing. But ultimately, that's a relatively small portion of water usage within the energy system. So this shows you overall how we withdraw water in the US for different human uses. And you can see that thermoelectric power plant cooling is the biggest source of water withdrawals, making up 41%. Irrigation is a close second, making up 37% of our water withdrawals. Again, this is withdrawals, it's not consumption. And as we talked about with thermoelectric power plant cooling, you ultimately return the water back to its original source. So if you look at this in terms of consumption, thermoelectric power plant cooling actually makes up less than 10% of our water consumption. Another thing to note is that this includes some saline water usage, saltwater usage, which is sometimes used for power plant cooling. This chart here makes adjustments for withdrawals and then also for that saline water to really show freshwater consumption in the US. All right, so not only does energy require water, but water resources also require energy. An estimated 13% of our energy consumption in the US is used to heat, treat, and move water. And in California, that percentage is even higher because of the increased water transportation needs that we have. This is a picture of the Edmonston pump that uses that pumps water over the Tehachapi Pass from Northern California into Southern California, which is a really critical source of water supply for Southern California. And it's one of the biggest point sources of power demand in our state. If you go to the California ISO, they'll talk about this pump being something that they need to monitor to make sure that the power usage doesn't spike above what's available in terms of energy supply in the area. All right, so let's take a look at freshwater consumption by each energy resource in the US. This is a chart that shows energy consumption, or excuse me, water consumption normalized based on the energy produced of each energy resource. So cubic meters of water used per gigajoule produced. So you can see that the worst performers in terms of water use per unit of energy delivered is geothermal. You'll talk about it in the geothermal lecture. It's a hydrothermal resource. You need water to bring that heat from the Earth's core up, and then also in the steam cycle to generate electricity from that heat. Hydropower also is really bad because you've got evaporation of water. This is something that surprised me when I saw this chart. You've got evaporation of water in those dams. But again, you've got the attribution question, right? Because those dams were made for other purposes beyond electricity generation, typically. Another significant poor performer is ethanol. That's because of water needed to grow corn. Today, about 10% of our gasoline is corn ethanol, and 30% of corn production in the US, I think corn is maybe our second biggest crop, maybe next to soybeans. 30% of corn production is converted to alcohol for ethanol. So the water and other resource inputs into growing that corn have significant environmental impacts, including from fertilizer production. And the best performers in terms of water usage are wind and solar, followed by oil and natural gas. I think that also surprises people, that oil and gas are among the best performers. Okay, so we talked about water withdrawals and consumption. Let's talk about water contamination. And these are a few examples of how oil spills have contaminated our waters. Whether you're talking about the BP Macondo Deepwater Horizon oil spill in 2010, which was one of the deadliest oil spills and most costly in history, or something that you'll talk more about in the oil lecture, maybe you already have. More recently, you've got the Red Hill Fuel Storage Facility on Oahu in Hawaii, which is fuels the Navy and supports military operations in the Pacific, was found to be a source of water contamination for the local community. Another big source of water contamination from our energy usage is coal ash. So coal ash is a byproduct of burning coal in power plants, and it contains a variety of different heavy metals and contaminants like mercury, cadmium, arsenic, and without proper management, can pollute waterways, groundwater, drinking water, and the air. Typically, if you go to a coal-fired power plant, probably one of the first things you're going to notice is a big uncovered pit of coal ash. Hopefully it's lined. Historically, though, they haven't been, and underneath. And the result is that coal ash seeps down into the water table and has been found to, many of these pits across the US have been found to have contaminated fresh water for the surrounding, which has significant negative impacts for the surrounding communities. Again, that mercury and air toxic standard helps regulate coal ash pits to make sure that they're lined so that doesn't happen. But again, that's on the target list for the current administration. Okay, let's talk about energy and land use. So there are really four main categories of energy-related land use to think about. You've got the land needed for upstream extraction, for things like mining or oil and gas drilling. Obviously, there's none needed for hydro, or for wind or for solar, because that resource occurs naturally in our environment. You've got land that's needed for the transportation of fuel or electricity, like oil and gas pipelines or transmission. You've got the land that's needed for the actual power plant itself. And then the final fourth category is land needed for downstream waste management, things like nuclear waste or coal ash. So this table here, it compares different electricity generation resources based on the land required for lifetime fuel production, as well as for the power plant area. And I purposely don't put this table in a chart because I think it can be deceiving, because there are other kind of non-numbers considerations to think about here, including the fact that, with large hydro, huge area needed for the power plant, typically with the big reservoir. But again, attribution is challenging, as most hydroelectric reservoirs are built for other purposes like irrigation and flood control. With wind, you've got big area needed for those wind turbines, but most of that isn't actually used for the turbines or the ancillary equipment themselves. So it can be dual use. It can be used for other purposes like pasture land and growing crops. So typically what we see with wind projects is that a wind developer will come in and lease land from a farmer and use only a small portion, 2% of that land, for the actual wind projects itself, and the rest of the land can still be used for those other purposes like grazing and growing crops. Solar, you might think, oh, it has actually quite a bit of land is needed for the power plant itself, but because it doesn't have any upstream extraction, the sun just shines, right? It doesn't require land to do that. If you look at both lifetime fuel production and power plant area together, solar is much more comparable to coal, nuclear, and natural gas. And of course, if you site solar on rooftops, then that has little to no land impacts. And that there's some data there on land usage for things like highways and transmission lines, pipelines, etc. And this table up top, it primarily shows electricity production source, but if you look again at ethanol, that really poor performer, ethanol has huge land impacts. This is a snapshot of how land is used in the US for agriculture, and you can see that the amount of land required for ethanol at the top where Michigan is significant. I think about 10% of our agricultural land use is for ethanol production, which is huge. Unfortunately, ethanol is a really poor performer on so many different environmental impact categories: land, water, greenhouse gas emissions, you name it. So that's land. Let's talk about the final environmental impact category, wildlife. And I want to talk about frameworks for thinking about wildlife impacts. To give an example, you probably hear a lot about how wind turbines kill bird deaths. You're probably going to hear a lot more about it in the coming 4 years. But it's important to think about that in context and ask questions like, how well does current regulation manage those impacts? Should we be worried about regulating other behaviors and human activity that have a greater impact on birds? As you can see in this table, relative to many other human activities, wind turbines actually have a relatively small impact on birds, with the top being cats. It's very sad when I saw this chart because I love cats, and my cat Mocha does kill birds and brings them to me as a present. But my cat Mocha is not going to kill a bald eagle, right, or a raptor. It's more likely to be the other way around. Normally, she'll go after those poor songbirds that aren't necessarily endangered. Another important question that you have to ask is, what type of species are being killed here, right? Because wind turbines are, like we talked about, more likely to kill the bigger birds that might be more endangered. But a really big question is, what is the alternative, right? If the alternative is continuing to use coal-fired power plants, climate change is going to have a huge impact on the extinction of species, much greater than wind turbines are going to have. This lecture has given you a sense that, and a big takeaway from this lecture is that, by and large, renewable energy resources are much better than their fossil fuel counterparts. So the significant clean energy transition that we're in the midst of is a boon for the environment, and all these other impacts to society as a result. But it's important to remember that there's no free lunch. Everything we do has an environmental impact, and we have to manage around that. Renewable energy resources and battery energy resources, electric vehicles in particular, have significantly higher mining impacts than their fossil fuel counterparts. They're much more minerals intensive. And that's something that we'll talk more about in the battery storage lecture and other lectures in this class as well. All right, so let's wrap up by talking a little bit about a concept of energy justice. We talked about environmental justice and how environmental impacts are disproportionately borne by marginalized communities, those low-income communities and communities of color. And this is also the case for the cost burden associated with our energy usage. So as you can see in this chart on the left, a significant portion of the population, over a fourth of the population, experiences some form of energy security. That means needing to make the hard choice between paying their utility bill and buying food and medicine, or leaving their homes at unsafe temperatures because they don't have enough money to pay their utility bill. And this is data from the EIA, the US Energy Information Association, from 2020. And 2020 was a time when our energy costs were at an all-time low, right? Because it was during COVID, energy demand was lower, so costs were lower. Since then, and continuing to today, we've seen significant increases in energy costs. The other thing I want to note about this data is it only looks at electricity, right? Electricity and gas for people's homes. It doesn't account for gasoline for people's cars, which is another significant portion of our energy use. So if you account for household expenditures on electricity, natural gas, and gasoline for cars, more than 15% of the population spends over a third of their income on energy expenditures. And I think there are interesting corollaries with affordable housing. U.S. Housing and Urban Development, Department of Housing and Urban Development defines affordable housing as housing for which occupants are paying no more than 30% of their income on housing costs. So pretty significant. I mean, I think you hear people talk a lot about our affordable housing crisis, but we also have affordable energy crisis here, where that access to reliable and affordable energy is critical for people in having basic human services. The good news is that there are a variety of different cost-effective measures that can be taken, clean energy measures that can both help reduce energy costs and also reduce the environmental impacts associated with our energy usage, including energy efficiency and weatherization measures in the home, everything from duct sealing and insulation to getting a more efficient HVAC unit, heating, ventilation, and air conditioning, installing a heat pump, obviously low-hanging fruit ones, LED lighting. Hopefully nobody here has incandescents in their home. So these measures, they have the potential to significantly reduce energy cost burdens, which is what this study on the left from DOE really looked at. How much can we reduce energy cost burdens for low-income households by taking cost-effective clean energy measures. Beyond those measures in the home, there's also significant benefits with electrifying transportation, right? Getting an EV. Because electricity is significantly lower cost than gasoline or other fossil fuel counterparts that might be used in the transportation sector. By converting to an electric vehicle, you can cut your gasoline costs and your operations and maintenance costs in the vehicle by more than half. Because an electric vehicle, you don't have an engine, it's a much more simplified transmission, there's a lot less moving parts. So there's pretty much the main maintenance that you have to think about are the wheels. So significant benefits alone, and if you and you can also get incentives for buying an electric vehicle and installing an EV charger, whether you're a household or a business, or even a nonprofit. You can access these tax credits. Hopefully, they will survive reconciliation. Something to keep an eye on. But luckily, we see bipartisan support for a lot of the federal tax credits for clean energy measures. So fingers crossed. All right, so this just shows the payback of different types of an electric vehicle. I've got a Volkswagen ID4. And so this compares the economics of a Volkswagen ID4 in the first year of ownership to the fossil fuel counterpart. So one of the things that you, I think, had in your readings was a video on environmental justice and this concept of the donut hole, right? Where clean energy measures, they provide all these different benefits, but why aren't they getting taken advantage of? And it's in part access to capital, right? Because you've got high-income folks that have the capability to invest in these measures and reap the benefits involved. You've got the very low-income folks that have a lot of different government programs supporting them and that will hopefully continue to support them, like DOE's Weatherization Assistance Program. But then you've got this missing middle, right, where you've got folks that probably lower middle income folks that have challenges accessing capital and would need increased access to capital in order to take advantage of clean energy opportunities. So in addition to that lack of access to capital, other challenges might be they don't have information on what the most cost-effective measures are. They can't find information on the incentives that are available to them, whether from the federal government or their utility or state entities. Maybe they can't find a contractor to install the measure, right? I don't know about here in the Bay Area, but in Nevada, you're hard-pressed to find a contractor that knows how to install a heat pump correctly. And then that lack of access to capital. So that's really what green banks do is they help address all of these challenges for different stakeholders, whether you're talking about households, school districts, small businesses. They will vet contractors, provide accessible and low-cost capital, provide education and technical assistance for navigating these different measures. And maybe in another class, I'll talk a little bit more about the Nevada Clean Energy Fund specific programs that do that, like through our Solar for All program, our electric school bus program with school districts, and our tribal clean energy program. All right, thank you, everyone.